Hello friends, welcome. Welcome to this presentation from Risingpearl. I'm your friend, your host Roy, and today we are talking about series 1 where we're discussing real numbers. This is webisode number 3. Today's topic, Euclid's division lemma. So friends, let's get started. Now, what do we mean by Euclid's division lemma? Before we jump into that, friends, I hope that you have got a chance to take a look at the last webisode where we talked about real numbers. If you did not get a chance, I'm going to include the link down below in this video. Please take a look at that, and because this particular series is all about real numbers, so all of that knowledge will come really handy. So let's get started with Euclid's division lemma. So when we say Euclid's division lemma, Euclid's division lemma. Well, we know Euclid is the name of the famous mathematician who is also referred to sometimes as the father of geometry. We understand division. What is this word lemma? When we say the word lemma, what does it mean? What it means is lemma is a proven statement that is used to prove other statements. This is the actual definition of the word lemma. Lemma, proven statement that is used to prove other statements. Sometimes you will also see this is also known as Euclid's division algorithm. So the word lemma and algorithm are used interchangeably. Algorithm is nothing but a set of steps to do something. It's a well-defined set of steps to do something. So as you can recall, as you can see from here, friends, Euclid's division lemma or Euclid's division algorithm, it must be about division, right? With that said, let's look more into it. Now, friends, I'm going to take two random positive integers, any two integers. So let me pick two numbers. So maybe pick 13 and 4. And I want to divide 13 by 4. So let's do that. So if I were to divide 13 divided by 4, what do we get? So 4 is a divisor, 13 is the dividend. So 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 fours are 16. So 4 threes are 12. And 13 minus 12 is 1. Because 1 is less than 4, so our division process stops. So at this point we get a quotient 3 and remainder 1. Let me pick two more numbers. I'm thinking, well, we did a 2-digit, 1-digit. So how about we take a 3-digit, 100, and let's divide 100 by 8. So if we were to divide 100 by 8, so 100 divided by 8, so we will first take the two digits, so 8 ones are 8. Now 10 minus 8 is 2, and the 0 comes down. Now 8 twos are 16, and then 20 minus 16 is 4. 4 is less than 8. Again, the division process stops. So here we have 12 as quotient, 4 as remainder. And let's take our one final set of two numbers. Again, these are all random numbers we are taking. So this time, how about we take the number 20 and 5. And we will divide 20 by 5. So if I were to divide 20 by 5, so I will say 20 divided by 5. So 5 fours are 20. And in this case, my remainder is 0. So friends, few things about the division process, and this is nothing new for you. We have been seeing such divisions from our class 1, or whenever we started learning division. This is always how we have been doing our divisions, right? So some quick observations. So first of all, when we divide two numbers, we divide the bigger number by the smaller number. That is clearly it's understood. Second is that now for the remainder, sometimes we get 0, like in this case, and sometimes we get a non-zero number, right? So in this case, it was 1. Here remainder was 4. Here the remainder is 0. The other unique thing about remainder is that the remainder always is less than the divisor, right? So in this case it is 1, which is less than 4. Here it is 4, which is less than 8. Here it is 0. Now what if in this case, for example, the remainder were 8? If we had really 8 here, then I could have done 8 ones are 8, and then my new remainder would have been 0, right? As long as I have a remainder here which is more than divisor, I can continue the division process. Again, this is not new. This is something we have done, have seen for a long time. And one final thing, friends, is that we can express the dividend, right? The dividend in terms of the divisor 4 multiplied by quotient plus remainder, right? So here q is a quotient. Let's represent that by lowercase q, and remainder, let us represent that by lowercase r. So here this is quotient, and here this is a remainder, right? Okay, here this is a quotient and this is a remainder. Now, so in this case again, the dividend 13 is 4, which is divisor, multiplied by 3, which is quotient, plus remainder. Similarly, here 100 is a dividend. So I can write 100 as my divisor 8 multiplied by my quotient 12 plus my remainder 4. And here 20 can be written as 5 multiplied by 4 plus 0. So in this case, friends, like we just said, here this was my quotient and this one is my remainder. Similarly, here this is my quotient, right? And this is my remainder. So on and so forth. So you must be wondering, really, so far we have not discussed anything brand new. How is all this connected to Euclid's division lemma? And friends, that takes us to the official definition of Euclid's division lemma. Euclid's division lemma states that given positive integers a and b, so if I have two positive integers a and b, there exist unique integers q and r, q for quotient, r for remainder, satisfying a equals bq plus r, where r is greater than equal to 0 but less than b. So as you can see, that friends, what it is really saying is that I have two numbers a, and let's assume a is bigger than b. So a divided by b, if I were to do this division, so I will have something like this, right? And then if I continue this division, the division will go on, and I will finally have a quotient and I'll have a remainder. When I have this, then what I can do is I can write my dividend as a equal to my divisor multiplied by quotient plus remainder, in such a way that the value of the remainder r will be, it can be greater than or equal to 0. Remember that remainder can be 0. It can be greater than equal to 0, but it must be less than b. So in other words, Euclid's division lemma is nothing but exactly the long division process. So friends, in the next episode, we are going to take a look at some of the applications of Euclid's division lemma.